Hello and welcome back for the 3.6 video. In the last lesson, we learned about functions and how we can determine if something is a function using the vertical line test, using tables and such. And I did kind of mention notation, but we're going to focus on the notation of a function in this lesson. So it says f of x is how we read this letter. It's not a multiplication. We're saying that this is kind of like a machine. If you were going to make a part, let's say if I wanted to make this paperclip, there's a machine that will form this paperclip. And X is the input that goes into the machine. And the input here would be the metal that goes into the machine. And F is the machine itself that makes the paperclip. So I'm telling the reader when they see this symbol that X is my input. Okay, and the thing that comes out of X, F of X, is the range or the result. So we have the domain that goes in and the range or result that comes out. So for the job ad in the previous notes for lesson 3.5, we said y equals 18x. If we were going to use function notation, we would write it as f of x equals 18x. And so then we could say f of 2. So the reader knows that when I put 2 in, I'm talking about that person working 2 hours. So f of 2 would be 18 times 2 because I'm replacing x with 2, and that comes out to be 36. So we would say f of 2 equals 36. That tells the reader that when that person works 2 hours at that job in the advertisement, they make $36. So we can say that for a function, we have inputs. That's called our domain. And then they go into the rule, and whatever the rule tells them or the machine does, then the outputs come out. That's our range. So let's look at example 2. We have two functions. We have an f function and a g function. And A says, what is the f function evaluated at 3? So I'm putting 3 into my function for x. And 1 comes out. Letter B says, what if I evaluate g at a -2? So I'm replacing x with a -2. And notice that x is being squared, so I have to put a -2 in parentheses so that the entire -2 gets multiplied by itself. So this becomes 4 minus 6 plus 4 results in a +2. Letter C says evaluate g at a plus 6. So that means all of a plus 6 goes in for x. So that means I have to take a plus 6 and I have to square that, plus 3 times a plus 6 plus 4. So off to the side, I'm going to do this a plus 6 times a plus 6, because we have to remember that a squared means that we're taking what's in the parentheses and multiplying by itself. And this is not just a squared plus 6 squared, it's actually having to FOIL. Remember our first, outside, inside, and last. So we have a squared plus 6a plus another 6a plus 6 times 6 is 36. So when we simplify this piece, it's a squared plus 12a plus 36. So that goes back into my evaluation here. So a squared plus 12a plus 36. And then I have to distribute this 3. So plus 3a plus 3 times 6 is 18 plus 4. And now I'm just gathering my like terms together. So I only have the a squared. I'm going to cross that off. I've got 12a and 3a. So plus 15a And then 36 and 18 is 54, plus 4 is 58. So that is the result. Okay, let's look at this in a contextual, real life kind of problem. It says, suppose X represents the one of the years in the chart. So we've got this picture down here. It says cameras all around, and it's got years at the bottom, 2010, 11, 12, 2013, 2014, 2015. And it says on the vertical, numbers sold in millions. So it must be cameras sold in these years. And the white looks like it's digital cameras, and the dark is smartphones. So cameras on a smartphone. So it says, suppose further that we have three functions. We have F, G, and H that do the following. Mistake there. F pairs each year with the number of smartphones sold that year. G pairs each year with the number of digital cameras sold that year. So F is the gray color, and the digital cameras is the white. H is such that we add them together. So it would be the total. So the white is just the space that's white, and the gray is just the space that's gray. Okay. And now we're going to do things with them. It says, for each of the following, indicate whether the statement is true or false. The domain of F is 2010 through 2015. Domain is what is going in, and that's usually our X. Domain usually refers to X. So we would say that that is true. That is our domain. B says H of 2011 is equal to 188 million. So H of 2011, H we said was them added together. So that would be all of 2011. Does that look like about 188 million? And no, because it's bigger than 200. It's 208. So that's false. Okay, then it says F of 2014 is bigger than G of 2014. So remember, F is the gray. So they're saying that gray is bigger than the white for 2014. Let's go to 2014. The gray is bigger than the white. That's true. The gray space is bigger than the white. So that one is true. D says F of 2010 is less than F of 2011. So now we're talking only about the gray. And they're saying the gray of 2010 is less than the gray of 2011. And yes, it looks like the gray is less on the 2010 than 2011. So that would be true. And then E says H of 2015, so that's them all added together, which is up here in the graph is all of this all of this 226 is greater than if we add H of 2013 and H of 2010. Okay, so we're saying 2015 is bigger than 2013. That's true. And is that bigger than 2010? That is true. So 2015 is bigger than 2013, which is also bigger than 2010. That is also true. You're doing great. Okay, so we're going to use some function notation to do some more evaluating. So let's evaluate G at 0. We have two functions again. We're going to evaluate G at 0. So X is going to get replaced with 0. And this becomes 0 minus 1 is a negative 1. G of a negative 1. So we're going to replace with X of a negative 1. So that is a negative 2 minus 1 is a negative 3. And then G of A plus 2. So that's going to be 2 times a plus 2 minus 1. So distributing the 2, we get 2a plus 4 minus 1 is 2a plus 3. We didn't use the f function at all. Now, in example 5, it says we've got an f function and a g function. And it says we want to evaluate the f function at a -1 and add that to the g function evaluated at 3. So let's evaluate the f function at a -1. So that'll be a -1 squared minus 2 times a -1. So that is a -1 squared is 1. A -2 times a -1 is +2. And so that results in 3. And then g evaluated at a -3 is a -15. Subtracting 4 is a -19. And we wanted to add them together. So 3 plus a -19 is a -16 is our final answer. Now B says G, and then we've got F and then 3. So this means that 3 is going into F of X, and then that result is going into G of X. So let's let X equal to be 3 into F of X. You should be writing all this down because this is a two-stepper. So we're going to put 3 into X. So we have 9 minus 6, and that's weird because that comes out to be 3. And now that goes into G. So we have 5 times 3 minus 4 is 15 minus 4, or 11. These two-steppers are tricky. Let's do another one. This time, it's f of g of 2. So let's write that out. F of g of 2. And so we read left to right, but we actually put them in right to left. So 2 goes into g of x, which will go into f of x. That's how that works. So we're going to say g of 2 first, which is 5 times 2 minus 4 is 10 minus 4 is 6. And then that means 6 goes into the f function. So 6 squared minus 2 times 6 is 36 minus 12 is 40. No, it's 24. So 2 goes into G. We did that up here. 2 is our input into G, and 6 came out. And then that result goes into F. So 6 goes into F. Catch me back for another lesson.